Hey guys, welcome to Computing Foundations, a channel for beginners who want to learn about computers, computer programming, and the math, science, and art behind this world-changing field. I'm Josh, a retired software engineer. Please subscribe, like, and share your comments to help us improve the channel. All right, today we're continuing our journey in learning the C programming language, and we're going to focus today on what I think is going to be for you a really exciting advance, and that is the statements of the C language that allow us to do flow of control, what's called flow of control. Don't worry, we're going to walk through each of them together. All right, so flow of control is how we write a program that isn't always going to do the exact same thing in a linear format. It may take different paths through the program depending on the values that are input or the values that are read from a file. So the first thing we want to review are what are called conditional statements. So look at this example here. Let's imagine I define a variable called age and I set it equal to 45. Then I can make a statement like this. If age is less than 50, then if it is, we're going to do something. And we'll talk about what we're going to do here in a second. But let's take a look at this statement carefully. Remember that whenever I write a variable or a number, and then this operator less than, and then another variable or number, I'm making a comparison statement. This statement will always return 0 or 1. It returns 0 if it's false. It returns 1 if it's true. So this new statement here that we're learning, if, it says, if whatever you placed inside these parentheses evaluates to a non-zero, if it evaluates to 1, if it's true, then I will execute what is inside these curly brackets. This is our first time seeing curly brackets in our programming examples. These are going to be really important. We'll learn more about them in a future video. But basically, they are used to enclose the body of this if statement. So this here is the if statement, is what we will call it. And everything that's between these two curly brackets is called the body of the if statement. So everything in the body of the if statement will be executed if the statement's correct. Now take a look at this. The if statement doesn't stop here. We can do a little more. You can add to the end of the if statement another statement called else if. It looks like this. You would say else if age is greater than 100, and then we'll come here. We could say, hey, okay, if your age is less than 50, we're going to print to the screen, you're not over the hill yet. Okay, but what happens if age is not less than 50? Okay, so it might be any number 50 or greater. Well, now I execute another if statement. I say, well, okay, if this wasn't true, check this. What about if the age is greater than 100? I might print something out like, I won't write the whole statement, but something like, wow, you're really old. Or maybe we might want to print, you represent 0.5% of the living population, because it's very rare to be 100 years old or over 100 years old. Okay, we can keep going. Watch this. We have another thing we can add to the statement. We could say else, and then we could have a final body where we would basically be saying, if none of the previous things were true, then execute this. So here we might say something like, welcome to the over 50 club. Again, I'm not writing the full print statement. I'm just explaining we could put a print statement here. So the if-else conditional statement is used to test different conditions, and depending on which condition is found to be true, we will execute the body. The statement will never execute more than one of its bodies, one of its clauses. If any of these are found to be true, the statement just stops. It will not continue evaluating. So, as an example, if I had said here, age is less than 40, okay, we never would have executed this else if, because any age that is less than 40 would also be less than 50. So this very first condition would have caught that variable. It would have been less than 50, and we never would have gotten to the second else if, where we asked if age was less than 40. So just understand only one of these is going to execute. Okay, this is the conditional statement. Very powerful. It gets used all the time in programming. So we're going to play with it in our sample program here at the end. All right, let me also walk you through a little variation that we can take on the if statement. I'm not a big fan of this, but I just wanted you to be aware that this is available to you. It's another way to write an if statement. So here I've defined a variable, a character called age category. And look at this. I write a conditional statement. Age is less than 50. Then I place a question mark. Then I'm allowed to place two statements in parentheses. Actually, I don't think you have to put them in parentheses, but it's good practice. Separated by a colon. What this is saying is, evaluate this conditional statement. If it's true, meaning if it's non-zero, then execute this first statement that I've placed after the question mark. If it's false, execute the second statement. This is another kind of if-else statement. So here I'm saying, hey, if age is less than 0, I'm going to set your age category to be O for old. Actually, I got that backwards. I think what I should have said is young. If your age is less than 50, age category equals Y for you are young. Otherwise, if you're not less than 50, you're over 50, your age category is O for old. So I messed up my example here. But the point is, depending on whether it's less than or greater than, I can run one or the other of these two statements. So again, here in the first section, we define a condition using our conditional operators. In the next statement, this is going to execute if our condition is true, which means, again, T-R-U-E, true, I can spell. If our statement is true, meaning non-zero, otherwise, this will execute if it's false. All right, so another variation on how I can execute an if statement. I just called this the compact if statement. Very rarely you may see this in some code. It's not super popular. All right, let's look at the next section. The other kind of flow of control we can do is a loop. In all of the programs that we've done so far, if we wanted to do something more than once, we just had to write the statements more than once. If I wanted to print out hello world 10 times, I would just have to write the statement printf hello world semicolon, printf hello world semicolon. I'd have to write it out 10 times to get the program to do it 10 times. Well, there is another way, a better way, a very powerful way called looping. And there's several kinds of loops. Let's start with the first one called the for loop. The for loop allows us to repeat a statement a set number of times. So we use the for loop when we know how many times we want to execute the statement. We can be very specific. Here's what the for loop looks like. So I'm defining a variable called number of executions and setting it to 0. We'll observe this here in a second. I'm going to show you how we're going to use that variable. But here's the for statement. For, open parentheses. This first section here is called initialization. Initialize. It only runs one time, and it happens before the loop begins. So the first statement that I'm executing is I declare an integer, int I equals 0. This is almost always what the beginning of a for loop will look like. Everybody almost always uses a variable called I, which means index or iterator, or it just means a variable that you're using to count your way through the loop. Int I equals 0, semicolon. The next section is called a condition. This is a conditional statement. It may or may not be true. This is going to execute before each iteration through your loop. So we execute this as many times as the loop is going to exist. And then lastly, this is called the post execution. So after each round through the loop, we execute this statement. Here, this statement is I++. It is a statement that will increment the value of I by 1. All right, so look at how I've defined the rest of my body here. I've said each time I go through this loop, I'm going to say number of exceptions plus equals 1. Can't quite recall if I went over this in a video or not, but plus equals is just a simple way to increment a variable. So if I say variable plus equals x, what I'm saying is variable var equals var plus x. So this is literally just a way to say I want to add x to my variable, and then assign that value back into the variable. This is just a simple way to increment a variable or by 1 or by another amount. You could replace this in this case with just num of executions plus, which would just augment num of executions by 1. That's another way to write it. Just multiple ways you can increase a variable by 1. All right, so let's take a look at what is actually going to happen when this loop executes. So the first thing that's going to happen is I gets set to 0. So I'm gonna do a little trace through here. I'm going to say, all right, I is equal to 0. We test the condition. Is I less than 10? Yep, I is less than 10. All right, now we execute what's happening here. We increase number of executions by 1. So when I equals 0, I'm going to enter the loop, and I will set number of executions to 1. All right. Now, finally, I've finished the statement. I'm going to increment I. So now I is going to be equal to 1. I come back into testing the condition. Is 1 less than 10? Yes, 1 is less than 10. All right. I execute this statement. So number of executions is now going to become 2. I is going to get incremented now to the number 2. So I++ equals 2. Is 2 less than 10? Yes. So we execute number of executions. Now number of executions will be incremented to the value 3. As you can see, we're going to continue all the way through as I equals 3, 4, 5, 6, 7, 8, 9, and then we'll stop. So let me walk you through this, what's happened, to make sure you agree with me. When I equals 3, we'll increment number of executions. It's going to now be set to 4. When it equals 4, we'll increment it again. It'll be 5. When it equals 5, 6. When it equals 6, 7. When it equals 7, 8. When it equals 8, 9. When it equals 9, 10. Okay. Now we've just finished executing the value I equals 9. We increase I by 1 again, so now I becomes the value 10. Okay. And we now run the test again. Is 10 less than 10? It's not. 10 is not less than 10. So this entire body of code, this entire for statement, everything inside the brackets, finishes when I equals 10. So we never execute the stuff inside the loop when I equals 10 because 10 is not less than 10. And we fall out and we exit the loop, and the next statement in the program will get executed. So if I set up a loop like this, I initialize I to 0. I say I'm going to run the loop until I is less than 10. And after each run of the loop, I'm going to increment I by 1. I will end up executing the code here 10 times. I will execute the code 10 times for the values of I in between 0 and 9. All right? I'm going to draw some little separators here so you can see a little more clearly. I should have made a better space. All right, hopefully that is clear. Now, so guess what I'm saying here is at the end, if I executed printf percent integer num of executions, this would print out to the screen the number 10. Okay? That's the for loop. Super powerful. You're going to use it a lot in your programming career. All right, let's take a look at the next kind of looping that we can do. This is called a while loop. Now, while loops tend to get used when you want to execute code, but you don't exactly know how many times you want to execute it. The number of times that you will execute it is going to depend on something out of your control that you don't quite know as you're writing the program. Okay? So let's take a look at my example. Integer, random number sum equals 0. Okay, random number sum equals 0. Then I'm going to say, as long as the random number sum is less than 100, execute the following body. Okay, and I'm going to talk you through what this body is going to do here in just a second. But let's make sure we understand the components of the while statement. This here is the while statement. And everything in between the two brackets is the body of the while statement. So what happens here is the program encounters the while statement. It verifies this conditional, and if it is true, if it's greater than 1, which right now, since I set random number sum to 0, it will be less than 100. As long as this is true, we're going to execute this code one time. Then after we execute it, we'll test the condition again. So we're going to continue executing this code while the condition is true. Now look at what I'm doing here. I use this to give you a good example of when you might use a while statement instead of a for statement. So what I'm saying here is random number sum plus equals, I'm calling a function that's called the random function. I'm doing a modulo operation by 10. So I'm going to increase the value of random number sum by whatever value this evaluates to. So let me explain to you what this does quickly. The random function in C returns a number, an integer number, somewhere between 0 and I believe it's like 32,000. So it gives us a semi-random number, just rolls the dice and picks a number for us. Now, what happens when I do a modulo by 10? Let's take a look at this and what the result will be. So imagine that I had the number 0 and I took the modulo 10 of that. What is the remainder of dividing 0 by 10? Well, the remainder equals 0. What's the remainder of 1 divided by 10? It's going to be equal to 1. 2 divided by 10. It's going to be equal to 2. We can continue this all the way until we get to 9 modulo 10 equals 9. And then on the next step here of my series, if I say 10 modulo by 10, I'm back to 0. 10 goes evenly into 10. 10 will evenly divide 10, so the remainder is 0. So as you can see, if I have a number, any number, and I take its modulo by 10, the result will be a number between 0 and 9. So when I modulo by 10, I'm saying, give me a number between 0 and 9. So when I take this random number and I modulo it by 10, I'm saying no matter what the random number was, it's some number between 0 and 32,000. Modulo it by 10, so that number is going to get turned into some number between 0 and 9. All right, so I'm going to increase random number sum by some number between 0 or 9. I don't know what the number is because the computer is randomly going to pick it for me. Now, if I print out here, what is random number sum, we would see that random number sum had increased by some value between 0 and 9. Now, it can't be greater than 9. 9 is the biggest number it could have possibly increased by. So then I'll come back and recheck random number sum is less than 100. It will be less than 100. That's guaranteed. So we're going to execute again. And again, I'll increase the random number sum by some number between 0 and 9. So potentially, after I execute this statement, it could be as big as 18. Don't know exactly what it's going to be, but it could be as big as 18. But 18 is still less than 100. So I'll execute again all the way until I reach 100. Now, the while loop was a good choice in this case because I don't exactly know how many times it's going to take me to finish this process. The computer is randomly picking numbers for me, so each time I run the program, I might potentially end up running this loop a different number of times. I invite you to take this code and try it out. See, put it in your own program and play around to see what happens and how many times you run through the loop will change each time you run the program. So that's the use of the while loop. Okay, quickly, let's look at another kind of loop. It's called the do-while loop. So the do-while loop is very similar to the while loop. Look at it here. I start with a statement with a word do. This is the opening of the do-while loop. Then I express between parentheses the body of the loop. Finally, I write a while, and then in parentheses, I have a conditional. And notice I have to add a semicolon after the conditional. So what is this statement saying? It's saying, I want you to execute the code in between these curly braces one time. Then I want you to check this condition. If the condition is true, execute it again. If the condition is not true, you don't need to execute it again. So it's just like the while statement with one exception. we're always going to execute it once because we don't check the condition until after the first execution. So look at my little silly program. I've created a character called ANS for answer. I ask the user, would you like to repeat this? Yes or no? Then I ask the user for input. I'm going to read in a character from the user into my variable answer. Now finally, after I've done this once, I will evaluate the expression. If answer does not equal no, so as long as the user doesn't enter in for no, I'm going to come back and execute this statement again. And the program will execute this statement as many times as necessary until the user finally enters a no. And then the do while statement will exit and we will go to the next line of the program. So this is the do while statement. All right, you are now officially getting dangerous. You've learned the basics of variables, assignment, math operators, comparison operators, and now the incredibly powerful flow of control statements in the C language. There is one other flow of control statement called a switch statement that is not as popular, but it is very useful. I've shown you an example of the switch statement in this week's example program. That is program number 7. It's called flow of control. So check out program number 7, flow of control, and you'll see examples of all the types of flows of control that we went over today, plus an additional type called the switch statement. Since I didn't go over it today, maybe we'll discuss the switch statement in another example program one day. All right, now for the first time, I want to give you a programming challenge. You've now got enough information that I can give you an interesting problem to solve. What I'd like you to do is take the challenge, go and try to write your own program that solves the challenge. Now, honestly, this may be a struggle. You may not be able to figure this out. That's okay. Just try, struggle with it a little bit, get stuck, okay? Maybe you'll solve it, maybe you won't, but give it a good try. Then, if you'll look at the program 07 Challenge, you'll see a working example of how to solve the program so you can figure out what you did wrong. All right, what is the program we're going to solve? This is a simple challenge. I want you to write a program that will find the quantity of prime numbers that exist between 2, which is the first prime number, and 4,294,967,295. Why did I pick that funny number? Well, this is the largest value that can be represented by a 32-bit number. So 2 to the 32 minus 1 equals this big 4 billion number. And if you remember from our lessons on variable types, there are specific variable types that are able to hold a number that is this large. I'll give you a hint. An integer cannot hold a number this large because integers can be positive and negative, meaning they have to split this range where half of the range goes to the negative numbers and half of the range goes to the positive numbers. So if you want a variable that can represent this number, you can't use an int. So you need to use something else. All right, so we're going to be searching for the prime numbers. What is a prime number? Just as a quick reminder in case you've forgotten your math, which is fine, we all forget our math. A prime number is any integer that is only divisible by 1 and itself. There is no other number that will divide evenly into a prime number except itself and the number 1. So a couple quick examples. A prime number is 2. It's only divisible by 1 and 2. The next prime number is 3. The next prime number is 5. The next prime number is 7. You get the idea. So what we're going to do is write a program where we loop through all of the numbers between 2 and 4 billion. And then for each number, we need to test, is it evenly divisible by any other number except 1 and itself? So the way we're going to do this is we're going to create a loop that will walk through all 4 billion numbers, and then for each number, we'll create another loop that will test to see, is there any number that will divide into this number? Now, this program will take quite a while to run. Mine is still running right now. It's been running now for about 3 hours. If you don't have time for it to run for 3 hours, feel free to reduce this number. You don't have to find all the prime values all the way to 4 billion. You can make it to 1 million, say. But I think I always kind of found it intriguing that I could write a program that my computer could not instantly run. That the computer is fast, but it's not that fast. It does have to do work, and this is a big problem we're asking it to solve. It will take your computer several hours to solve it. Okay, but it'll really take a long time to solve it if you don't do this wisely. So let me give you some advice. Any given number, let's take the number 10, okay? If I half the number and get the number 5, I would say that if any number is going to divide into 10 evenly, okay, it has to be less than or equal to 5. I mean, any number bigger than half the size of the number you're dividing isn't going to go into the number evenly. So your first clue is you only need to test the numbers that are less than half the value of the number that you're trying to evaluate. So if I'm evaluating 10, is 10 a prime number? I only need to see if it's evenly divisible by the numbers less than half. Okay, actually though, we can do even better than that. Let me show you. Let's remember from our math the square root. So the square root of a number, n, let's say it's x. Now that's only true. X is the square root of n if and only if x multiplied by x equals n. So the square root of n, x, if I square x, it equals n. Let's look at some basic examples here. What is the square root of 4? It's 2. What's the square root of 6? It's, oops, I actually got that wrong. The square root of 6 is not 3. Sorry. 9. The square root of 9 is 3 because 3 times 3 equals 9. Making sure you can see that here. I'm going to say 9 because I screwed up my number. All right, what's the next one? 16. What's the square root of 16? 4, because 4 times 4 is 16. What's the square root of 25? 5. 5 times 5 equals 25. Now, what about all the numbers that come in between? Okay, what's the square root of 5? What's the square root of 6? What's the square root of 7? What's the square root of 8? Okay? Well, I don't know it off the top of my head, but whatever the square root of these numbers is, it must be between 2 and 3, because 3 is the square root of 9, so whatever the square roots of these numbers are, it has to be less than 3. It's got to be greater than 2, so the square root is in here somewhere. And the same thing here for the square root of, sorry, I got my numbers wrong again, the square root of 10, 11, 12, 13, 14, and 15. Okay, they're somewhere between 3 and 4. And the same thing down here. All right, you get the idea. Now, so you're refamiliarized with what is a square root. Now, let's take a look at this. If n is not a prime number, then there must exist 2 other numbers that if I multiply them together, they will equal n. 2 numbers besides 1 and the number itself, okay? Because 1 and the number itself, every number is divisible by 1 in itself. All right, so there exists two numbers that when multiplied will equal n. Let's look at some examples. 8 is not a prime number because 2 times 4 equals 8. 6 is not a prime number because 2 times 3 equals 6. 10 is not a prime number because 2 times 5 equals 10. And here we go with more and more examples. Some numbers like 16, well, there's two different possible combinations of numbers that will get me 16. Hopefully, this is all easy peasy for you. All right. I want you to notice something. In all of these examples, at least one of the factors, these are called factors, that I'm multiplying to get the number, at least one of them is less than or equal to the square root of n. Okay? So let's take a look here. What is the square root of 16? It's 4. Notice here, in both of these factorizations of 16, there exists a number that is less than or equal to 4. Here the number is 2. Here the number is 4. 4 is less than or equal to 4. Let's look at 20. What's the square root of 20? Well, I don't know what the square root of 20 is, but I know that it's somewhere between 4 and 5. It has to be greater than 4, less than 5. Okay? So what does that mean? It means if there's any number that's going to go into 20, it's going to be less than or equal to 4. Okay? So here we see 2 and 4. So in all of these examples, my point that I'm trying to make is one factor of every non-prime is always less than or equal to its square root. So here, if n equals a times b, if a and b both are greater than the square root of n, well, there's no way their product could be n, because the square root of n times the square root of n equals n. So if one of the numbers is bigger than the square root, or sorry, if both of the numbers are bigger than the square root, there's no way the product could be equal to the number. Okay, all of this mumbo jumbo to say, when you're building your loops, once you've picked a number, you're trying to decide if that number is, you're trying to decide if that number is prime or not. You only need to test the numbers from 2 up to the square root of the number. And you can find the square root of any number in the C language by just saying SQRT and then add the number into parentheses. And in order for this to work correctly in your program, you will have to include, #include, math.h. So the math functions are in the math.h library. Once you include math.h, you will have the square root function, and this function will be able to tell you what is the square root of the number you're evaluating. You only need to test if it's divisible by some number between 2 and the square root. All right, that's it. I hope you guys enjoyed today's lesson. I think we're getting to some really powerful stuff now that should be getting exciting. Take a look at program 7 on flow of control, and then after you've done that, take a crack at this challenge. And once you've done that, you can look at the answer in the program challenge. This is 07-challenge is the name of the file where you'll find the answer. All right, have a good day, and we'll see you next time.